Hello, everyone. My name is Nia Robinson. I'm a computer science major sophomore at Carnegie Mellon University, and I am a TA teaching assistant with CS Academy. Today, we're going to be looking at how we can build a Pascal holiday tree based on Pascal's triangle, which is a famous mathematical structure, I guess you could say. It holds a lot of applications to different mathematical patterns. This video is made for more advanced students, so ideally you're a little bit comfortable with recursion and definitely comfortable with working with two-dimensional 2D arrays, both of which are covered in CS Academy, some in our later levels of learning. So let's hop right in. The first thing I want to talk about is to clarify what is Pascal's triangle. This is a wonderful mathematical structure that has applications everywhere. It was discovered at different times around the globe. Different peoples were able to put it in writing and draw this out, yet it is known today most popularly by the French mathematician Blaise Pascal. And you can see it looks like this. The outsides have ones, and then when you calculate all of the other things, you look at the two values that are above that spot. As you can see from this animation, you get 1 and 3, you get 4. 3 and 3, you get 6. 3 and 1, you get 4. This whole thing repeats for as many levels as you want, going all the way down. Has lots of applications to lots of different mathematical theories and structures, like binomial coefficients, which can help with probability theory, binomial expansions, which is applicable in calculus and function estimations. You have lots of patterns like Sierpinski's triangle, and that is if you only choose the odd, like if you only color in the odd numbers in the triangle, you will get Sierpinski's triangle. You can get the Fibonacci numbers, as you can see here, by adding down the diagonals. You get 1, 1, 2, 3, 5, 8, which is kind of similar to the triangle in a way, because with Fibonacci, you add the two numbers that come before it in the list, and there's many more applications. So this is something that a lot of times we'll be like doing a CS problem or doing a math problem, and it'll pop up and be like, oh, this relates to Pascal's triangle, or oh, this relates to Fibonacci, which relates to Pascal's triangle. And if you're really interested in finding out more of the patterns that Pascal's triangle exhibits, highly recommend getting a math degree. This is something that a lot of people in math can be interested in and learn about together. So what is our algorithm going to look like for creating this tree? The first thing that we need to do is create the data structure that we're going to use. We're going to use a 2D array, and I'll show you what that's going to look like. And that's going to hold all of the values for our Pascal's triangle. That's what we're going to do in part 2. We're going to recursively fill in the values of this triangle. So we're just going to start out with the bottom row and use that to work our way up recursively, all the way to our base case. And then finally, we can create and display the tree. And this is where we can get a little bit more creative. I have a very basic version of my tree, but you can add lights. You can make it for a specific holiday, whatever you would like. And that will get our creative juices flowing, and you can explore with the colors and the sizing of the tree and everything like that. So looking at our code, what we have, what I want to share is the code that I'm starting out with. So this function here, make list, this will make the 2D array that will represent our tree. This function, fill val, will fill in the list with the corresponding Pascal tree value. So this one here will just make it so that it creates a list with all zeros, and this one will fill it in. This function takes in just how many levels you want, and I'll explain that later because we're going to get some user input. This one takes in order to fill in a spot, we need to know the row that it's in, how far right in the tree we're going, and which tree we're going to be filling it into. This is kind of our biggest function. It's going to have a lot of the main control flow. Again, it's going to take in how many levels the user wants to see. We're going to call both of our early functions, and we're also going to display the tree using some other values, make our tree stump. Down here we have our main. which is where we're going to do our input. As you can see, when I run this, it asks how many levels would I like to draw. Let's say 5, say okay. Ideally, then it would draw us a Pascal's tree with 5 levels. So that is our goal. So that's the order, and you can see down here, this is what my tree looks like. This is with 8 levels, it looks like. So that's a little bit bigger of a tree, but you can see, again, you can customize it so that the trees are made smaller or bigger on the Canvas screen. So creating the data structure, this is our first thing that we need to do. This is going to be a 2-dimensional array. So what that means is each row will be an array, which will be in an overall bigger array or list, which will be called the row. So we'll go row by row. Row 0 will have a list of 1 thing, which represents this place here. Row 1 will have a list of 2 things. Row 2 will have a list of 3 things, and so on and so forth. And again, once we make this data structure, we're just going to be filling all this in with zeros initially. You could experiment with this where you fill it in as you go, but that might be a little bit more complicated, and we really want to set out the steps as very clearly as possible for this project because there's a lot going on. So we want to make sure whoever is coming in to read our code can easily understand what's happening. So let's go ahead and tackle this first part. Looking at our code, initially, I'm just going to call my list tree structure. In order to make a 2-dimensional array, we need 2 big things. Every time you make a 2-dimensional array, you're going to need 2 for loops. So I'm going to say for where the first thing that we're going to do is we're going to be creating our outer list. So we went ahead and called that row for row in range 1, comma, and then L is what we take in, which is the number of levels, L plus 1, and we have to do that because let's say in this situation here, we want a Pascal's triangle with 1, 2, 3, 4 rows. We're going to input 4, but the index of each of those rows are going to go 0 through 3. So there's just a little bit of an offset. So we're going to go from 1 to L plus 1. This way it all matches up. And then instead of going from 0 to L. And then we're going to make another for loop for, and let's call this right, which is how far right we are, in range row. So again, this is why we did the 1 to L plus 1, because we don't want an element, we don't want a row that has no spaces. And we're going to go ahead and create what that row list looks like that we're going to end up putting our zeros in. Let's just call this R, and we're going to make this into an empty list to begin with. And now what we can do is we can add in what we're going to append. So for every time this for loop runs, we're going to add 1 more thing to R, and we're just going to do r.append. And we're just going to append 0. Finally, after that for loop is done, we can say tree structure, a capital S there, append, and we're going to append this whole thing. So we're going to append R. Then all we have to do is return tree structure. So we did a 2D array by making 2 for loops. For each row, we created its own list. To that list, we added an appropriate number of zeros, appended that list to the bigger list of rows, and then we return the whole thing. And actually do ourselves a favor, we can print it as well to see how it comes out. So you can say tree structure. And when we run this, let's say we want 3 levels, we should get a big list that has little lists with 0, 0, 0, and 0, 0, 0 inside. Let's make sure this works. We want to test as we go. 0, 0, 0, 0, 0, 0. If you can imagine, this is the very top of our tree, this is the next level, and this is the next level. You can see how this data structure that we're using kind of emulates the structure of the Pascal's triangle. All right, now that we're done with that, we have this structure. Each one of these are filled with a 0. Now we need to fill in the actual numbers. So when we recursively fill in these numbers, we have 3 cases. First, which you can think of as kind of a case 0. Because it's recursive, we always need to think about our base case. You can think about our base case. We're going to be starting down here and working our way up for our recursive cases. So our base cases will be this top one right here. Whenever we get to the input 1, 1, where this is our first row and our first place to the right, we automatically just want to fill it in with a 1, and we won't use any recursive calls. That's what our base case means. We'll have an if here, and we'll say if our row is 0 and our right is 0, all we want to do is set that spot to 1. So we'll have tree, row, right equals 1. Just noting the syntax here, this is how we're going to access our 2D array. This will change this position here to a 1. Now we can look at our 3 cases. So think for a minute about why this number 1 here is position 3, 0, and how maybe we can detect that. We're going to have a separate if statement for whether it's on the left side, whether it's on the right side, or whether it's in the middle. Think for a moment how we can use if statements to detect each of these cases. Here's how I'm going to do it. Using else if statements, I'm going to check if something's on the left side of the tree first. So I will say if, and I'm checking if the right value, which again is how far right it is, equals 0, which is the case for this situation right here, case 1. Our right value is 0. If that is true, because this is recursive, whenever we're not at our base case, we always want to check to see if the cases above us has been filled. To do that, what we're going to do is we're just going to check if the thing above us is a 0. Because again, even if we filled in this first spot, say we're looking at this spot, we want to check if the one above us has been filled. If it hasn't been filled, we know that that value will presently be a 0. So we're going to say if tree, we're going to look at the row above us. It's row -1. And then right, the same right value. Again, we're still looking at that 0th position. If that equals 0, meaning it has not been filled, we're going to go ahead and call this function recursively to make sure we fill that in. Next, we want to fill ourselves in, so we're just going to say tree, row, right equals 1. Again, we know it will be a 1 because every value on the left and right sides of the tree will be a 1 on the outer edges. We're going to do something very similar for the right side. Think about for a moment, I'm just going to copy and paste. Think about for a moment what needs to change. Instead of the right equaling 0, we want to check if the right equals the row that we're in. So I'll say if the right equals the row that we're in here, and we can see this in here. This, we're looking at row 0, 1, 2, 3, 4, the 4th row. We want to check if right equals 0, 1, 2, 3, 4. That's how we know that we're on this right edge. If that is true, we want to go to the row before us, and we want to check the right -1, because if we're in the 4th row, The third row will not have a fourth value because it's a triangle. If that one's 0, meaning the value has not been filled in, we want to call our function recursively, and then we want to fill ourselves in, this current one in, with a 1 because it's on the right side of the triangle. Our last case is we have somewhere in the middle. I'm going to copy the beginning of this here. Think for a minute about what needs to change. I'll just do a regular else statement, because this is the only case left. So if the same position in the row before us, this one here, hasn't been filled, we want to go ahead and fill it. So if that one's 0, we're going to call this case recursively. We're also going to look at the one right above us, but also the one right above us and to the right one. So I'm going to copy this again. And we're going to be checking whether the one above us is 0 and also whether the one above us and to the right -1 is 0. So in this case 3, we want to get this value 6 by adding this 3 and this 3 here. Again, going back to our helpful animation, we want to take the 2 values that's above to create the next value below. The way I see it, we need to get the value that's on the left above us and the value that's on the right above us. So let's go ahead and make those variables. So I'm going to say upper right equals and upper left equals. We know that we're going to get this from the tree. It's going to be the row above us, so row -1. And if you're on the right above us, that will be just the right like this. Something very similar. Think about what needs to change to get what's on the left. I'm going to do the right -1. So this will get us the values that are up and to the left and up and to the right. This is our right -1, our upper left, our right -0, just right, up and to the right. Now that we have both the values we need to create this new value, let's add them together. So to create this position, we're going to say row right, the position that we're at right now. That will equal UR plus LR. And this will give us a completely filled in Pascal's triangle. And we can print this out. Maybe not here, because this function is recursive. In order to call this function, we do it for each of the values along the bottom row. So after this, I can print tree just to see how it looks. If I do print tree, we can run this. Again, we'll just do it for 3 levels. Oh no, an error. Let's see what it's saying. LR is not defined. Oops, UR. Okay, let's do it for 3 levels. Perfect. First 3 levels of Pascal's triangle. 1, 1, 1, 1, 2, 1. And just working through how this went, we ranged over all the different levels. So it went over this list here. Originally, this was a 0. Went to this one, it said, hey, the one above you is a 0. Let's change you. Let's change you, which is our base case. And then all that returned, it then went to here. It said, hey, you're a 0. And you're already filled, so we don't have to call you recursively. And no matter how big we want, how many levels, this recursive stepping will always work. Comment that out real quick. So the last thing that we need to do is display our tree. Now, this is going to get a little bit mathy because we have to figure out the math of the triangle. But what we're going to do, we're going to start at the bottom and work our way up, and use for loops to our advantage and a lot of variables. So the size / spacing of the tree can be completely up to you. Don't forget to add your stump and any more tree decor that you want to add. And then we'll talk in the end about some extra things that you might do to adjust your code to adapt the tree size to the input. So step 3, let me show you the variables that I've already created. So I'm going to be using triangles to do this. My tree is made out of triangles. You could use any shape you want. I'm doing a variable space, which is the space that each triangle has. I'm going to overlap them a little bit. So this is slightly less than the width of the triangle that I'm going to use. A starting X and a starting Y, which will determine where the bottom of the tree is. And that is about here. And an offset, which is about how much we offset each row by. This way, like, it creates a tree structure. I'm gonna be adding all of my trees to this group, final tree, and adding this to a group will not only allow us to place the stump perfectly in the middle, but if you want to add anything later to your tree, having this group available to you will be extremely helpful. For my for loops, again, I'm going to have something pretty similar to what I had earlier. I'm going to say for row, but I'm going to be using index for the row in the range of levels -1, -1, -1. This means that I'm starting at, let's say I want 5 levels. I'm starting at 4. Each time I'm subtracting by 1, and I'm doing this for loop until we get to -1. My second for loop, I'm going into the tree, into the right, and then we're just going to do this in the range of row +1. All right, first thing we're going to do is we're going to add the triangle. So I'm going to say final tree dot add. We're going to have a regular polygon to create our triangle. We're going to have, this is just going to stand in some X, some Y. And I'm going to make this a size 35, like the width. We're going to have 3 points on our polygon, and I'm going to fill it with green. Now we just need to figure out what this X and what this Y is going to be. And first, I'm just going to write something that's going to make it a little bit wrong, and then we can see how we can adjust it to make it correct. Again, this is all part of the process of checking as we go along, just jotting down what ideas you have and then tweaking them until you get it to where you want it to be, and it's perfect for what you need. For our X value, we're just going to start at our starting X value. You put it in there, so you might as well start there. And because we know, like, hey, each of these triangles are going to be spaced 30 apart, if I start here, I need to allow a space of 30 for the first thing, a space of 30 for the second, third, fourth. So in order to achieve that, to our starting X, we're going to add, right, how far right we are in the list, which is going to be like 0, 1, 2, ... And we're going to multiply that by how much space we are allowing for each triangle. So that is right times space. For our Y value, start out very similarly. Start out with the starting Y plus row, that's how far up we are, times space. Again, we're just allowing 30 on each side. So if we do this, let's see what happens. Let's run it. Let's say that we want 4 this time. So you can see that this is similar to the structure of our list that we made because we haven't made use of the offset yet. If you think about it, you can kind of see our array in here. This is our first level, second level, third level, fourth level, things like that. So like this is 0, 0, and so on and so forth. So obviously this is not what we want. We want that offset to come in and help us make these X values correct. In order to do that, we're going to add our offset into the X value here. And for this, we're going to add our offset times our row value. So you can kind of think about this as we're pushing it forward a little bit more each time. Now when we run this, say we want 4, a beautiful tree. Perfect. Final thing we have to do is we have to add in the actual numbers of Pascal's triangle, which luckily for us, we've already created. In the same for loop, we're going to add again to our group. This time we're going to add a label. Realize that. This label, we're going to do toString, which is a helpful function because everything is integers right now. We're going to get our position in the tree list that we built. Ensure I'm getting our parentheses all correct. And for the space of this, we want it to be the same space. We want each of the numbers to be kind of centered in our triangles, so we can copy the exact same X and Y values. Here's our X value. And there's our Y value. Now when I run this, let's hope our parentheses are correct. 4, oops, something is off. All right, looks like we have an error. It's calling our attention to line 79. It's saying that list indices must be an integer. Here I'm trying to do list indices. Looks like I did this incorrectly. Let's make that there. Run it. 5. Look at that. A beautiful Pascal's tree holiday themed. All right. Thank you everyone for listening. Just a couple of add-ons. I want to talk about what you can do to make this project your own. You can of course adjust which shapes you want to use. You can adjust how big the tree is. One thing that we can do is you can see when I input bigger and bigger numbers. So let's say I want 10 levels. This can get really big. This is still in frame. Let's say I want 15. This is getting out of frame. Our numbers are getting really big and I can't scroll side to side. So you can think about maybe, depending on how big your input is, adjusting the size of the tree so that it always fits in the window. You can think about being able to maybe add in a scrolling function so that you can see the tree, adding in a function where the numbers don't overlap, adding in lights, adding a star to the tree, different things to really make this project your own. Thank you so much for watching. Have a wonderful day.